Hello and welcome to R&D Mathematics. Today we are going to again talk about general form and standard form. Actually, today we will be converting from general to standard form. In quadratic equation. Now, first of all, let me recall you. Standard form is f of x equal a x minus h squared plus k. With these numbers, hk is the vertex. So, and if a is positive, it's upward, a is negative, it's downward. With this form, it's really easy to deal with if the function is given in this form. But general form, on the other hand, that's the case. Mostly a quadratic function will appear. Now, in this case, we learned some theory, vertex equal negative b over 2a. Yes, you can apply that, and f of that value, whatever you found, and then you go from there. Well, let's say take an example and see. Sometimes if you know how to convert from here to here, then it should be easy. Now let's take, for an example, f of x 3x squared minus 6x plus 4. Now, yes, you can apply this one, and in our last video we used this example to graph it. But now let's try to convert this into standard form. Basically, converting process depends on completing square. This technique, completing square technique. And let's say, first what you need to do, take that 3 out. So x squared minus 2x plus 4 over 3. Now we actually complete the square of this guy. So you first take the second number right here and divide it by 2. So you get minus 1, and then you square it. Now in your head, you know x minus 1 is x squared minus 2x plus 1, right? See this part here, that part, we created that part, and we have additional one here. So what we simply need to do, you write down that number and subtract that one, then they are the same. Do you get it? Because see, x minus 1 squared plus 4 over 3 minus 1, and you know this part is x squared minus 2x plus 1, and then plus 4 over 3 minus 1 plus 1, and this will cancel. You already have this part, which is exactly same as right here. So this is completing square, guys. So you have 3 and then x minus 1 squared, and if I simplify this part, I get 3 is the common denominator, so 4 minus 3, which is 1/4, sorry, 1 over 3, 1/3, and then when you multiply 3 by 1/3, you get 1. So we are in this form now. H comma k, h is 1, so vertex is going to be 1 comma 1. So 1 comma 1, and open upwards, and we have a graph like this, right? And let's see, sometimes knowing how to convert is really helpful. Again, it's basically based on completing square technique. Now let's see, what if I use this one? Actually we did it in last video, but let me quickly do it for you. Negative b, so negative 6, negative 6 divided by 2 times a, 2 times 3, which is 6, comma, see this guy is actually 1, right? Because positive 6 over 1, so f of 1. When I plug 1, 3 times 1 squared, which is 3, minus 6 plus 4, again I am getting 3 plus 4 is 7 minus 6 is 1, so 1 comma 1. See the same result. So you can simply convert using that and then move forward if you really like this one. That's normally how I would do. So you can avoid remembering this. But again, I explained you how this formula is coming from and I proved it in my last video. So I think now everything basically makes sense. One more comment. Let me see quadratic form. We are talking about quadratic functions. Now, last chapter we learned about quadratic equation. Now, at this point, everything must make sense. Now, what is a quadratic function? It appears in this form: fx equal, let's take example 3x squared minus 4x plus 6. And quadratic equation means if I take the same part, 3x squared minus 4x plus 6 equals 0. So this is a quadratic equation, this is a quadratic function. Now what's the difference between these two? Well, this is a function. When you apply x values, you keep getting different y values. Here you don't have that, it's just right hand side, one side is 0. So if you carefully observe it, like let's say, let me see, if you carefully observe it, let's assume our quadratic equation is like this. Let's just assume, I don't know what shape, but for the time being, let's just assume it looks like this. Quadratic function graph looks like this. Let's just assume. Now look at this place and this place. At those places, what is the function value? F of whatever, f of x, that is 0 from here, because y height is 0, right? So actually this guy is just one case out of infinitely many cases of this guy, right? This one is just one case of this guy. It's more general. So that's exactly why if your function like this, you have two solutions, and if your function look like this, touching your x-axis and going turning vertex happen to be at the x-axis. So in other words, y coordinate is 0. If that happens, only one solution. And if it happen to be like this or like this, where it will never touch x-axis, you have no solution. And I believe now everything finally make sense and everything is crystal clear. Okay guys, that's enough for today's video. Thank you.